Hello, I'm João Vitor, a psychology student, and welcome to this video where we'll talk about memory, types of memory, the nature of memory, and the neurological process of memory, how memory works from the brain's perspective and from the scientific standpoint. We don't exactly know what memory is, that is, what is the nature or Aristotelian substance is. We can identify, track, and classify, but we don't know exactly what memory is from a biological perspective. So, join me in this video as we explore and discuss today's topic. Neurons that fire together, wire together. And this connection between neurons are what we commonly know as synapses. Yes, students, neurons have everything to do with memories. Pay attention. The brain is essentially made up of neurons that send and receive information. Since brain communication occurs through chemical and electrical signs, glial cells are also important as they provide vital support to neurons. On average, we have 86 billion neurons in the brain, which form approximately 100 trillion connections or synapses. That means there are more connections in your brain than stars in the Milky Way. Yes, it's bizarre and frightening. Now observe with me the image of a neuron. Let's understand how it works. At one end, we have the dendrites, the nucleus, the vital part of the neuron, the cell body, soma, and the axon. In the middle, we have the myelin sheath, and at the other end, we have the axon terminals. So you, the psychology student, might ask,
What? Bro, what are you talking about, man?
but understanding this will help you to understand almost everything about human functioning. Pay attention. Dendrites and axons are fibrous branches that connect the neurons to other neurons and receptors. Think of dendrites as the message receiving part of the neuron. Most neurons have many dendrites that extend to collect information from neurons and receptors. In mature nervous cells, dendrites are constantly forming new connections and breaking old ones. The axon, simply put, is a part that sends information from the cell. It's like the sender. Generally, axons conduct information from the cell to neighboring neurons. The branch of a single axon can extend up to 90 centimeters, ensuring that the brain communicates with the entire body throughout the nervous system. As I mentioned at the beginning of the video, the nature or substance of a memory is a mystery. This means we don't know exactly what a memory is at a biological level. One of the most accepted theories recently is that memories are maintained through networks of neurons. Remember, the axon terminals of one neuron can connect with the dendrites of another neuron to transmit information electrically and chemically. Neurons physically connected creating something like a powered cable. These connections between neurons or synapses are strengthened when certain neurons communicate or fire together frequently. Remember Hebb's law? Neurons that fire together wire together. A series of connected neurons that encode a memory became known as an engram, a term coined by Richard Semon, a pioneer in this field. Interestingly, I discovered Richard Semon through Jung. In his book Psychological Types, Jung outlined his theory of archetypes and tried to explain it to a more educated scientific audience and asks them to make an analogy of the concept of engram, which was a very new concept at the time of Jung. It's quite interesting to notice that Jung recognized the importance of a concept of engram as early as around 1930, actually 1921, and made this connection with his theory of archetypes is extremely interesting and quite genius. According to this theory, a memory would be like a physical neural structure, the engram. You watching this video might ask, okay, all this makes sense, but why do we forget? Isn't there something like short memory, long-term memory, etc.? Yes, short-term memory is characterized by being limited in volume of information It can hold and last a few minutes or less if we get distracted. For example, think of someone giving you a phone number. For about 10 seconds, you'll be able to remember it perfectly, but after a few minutes, chances are you'll forget it. Similarly, when you meet someone new, you will naturally greet each other and they will tell you their names, and you will tell them yours. Okay. After a few minutes of conversation, we might notice that you're no longer sure of their names, creating an awkward situation for both of you. I don't know about you, but this always happens to me. So don't make it to the heart and don't feel bad about yourself. Blame short-term memory and that's it. It's alright. That's why the technique of mentally repeating a number or a name works, because it keeps the information in short-term memory longer. This technique leads up to another type of memory, working memory. It's very similar to short-term memory as it's often confused or used interchangeably with it. But in psychology, the difference lies in the fact that short-term memory simply stores and retains information, while working memory allows you to manipulate and articulate the stored information. An example is when you do mental math. You think of a number, it stays on your mental screen while you calculate it with another number to get the result. You use the result to give someone change, for example. But those numbers are not stored as memory. They were merely data that had an operational function. If someone asks you the next day what the numbers and the result were, chances are you completely forgotten. Now, pay attention to the soundtracks. If you had a decent childhood, you surely remember something in relation to these stimuli. But why don't we forget many things even after many years? Well, that's where a very important type of memory comes in, long-term memory. Unlike short-term memory, long-term memory is, at least theoretically, infinity. As memories are stored are combinations of neurons throughout the cortex, hippocampus, and other brain regions, there should be no limit to what we can store in long-term memory. It is believed that anything stored for minutes, hours, days, weeks, or years is handled by long-term memory. For example, your name, your date of birth, the taste of your grandmother's or mother's cake, or your favorite songs. In studies on the topic, long-term memories generally divide in two systems. First, we have declarative or explicit memory, which are those solid memories you can tell people without fear of being wrong. On the other hand, we have implicit or procedural memory, popularly known as motor memory, which includes things you can't explain how you do. Implicit memory includes procedural memories such as skills or habits like riding a bike, playing the piano, etc. To talk more deeply about memory, we must mention the hippocampus and its functions. And since we're talking about memory, don't forget to like this video and subscribe to the channel. Take advantage now that I've remembered you and this information is in your short-term memory. According to some studies, those who are subscribed to this channel and watch the videos until the end became smarter and their memory works better in college exams, public competitions, and more. And it's free. Then let's continue our conversation. The hippocampus is a structure located in the center of the brain. It's part of the famous limbic system. The hippocampus evolved to allow us to store memories, so it's fundamental in the memory consolidation process, while working memory and short-term memory primarily operate in the prefrontal cortex, our consciousness or mental screen. The hippocampus is the agent responsible for turning these into long-term memory, recording them in cortical regions, the parietal lobe, association areas of the neocortex, etc. So, think of the hippocampus as a pattern detecting agent. We receive information through sensory stimuli, such as a song you like it or hate it, the song passes through the auditory cortex and other regions. The more times you hear this song, the hippocampus will notice that this stimulus has a recognizable pattern. It activated the same brain regions and therefore fired the same neurons. Remember Hebb's law. Neurons that fire together wire together. By the way, if you understood this, it means you have a very solid memory of a language called English. But moving on, this happens because when a neuron repeatedly activates another, a phenomenon called long-term potentiation occurs. Long-term potentiation is what makes a synapse, so to speak, remember the stimulus that activated it. This phenomenon strengthens and deepens the connections between neurons. This happens in various ways, but since you don't want to overload your short-term memory, my dear subscriber, the important thing is to remember that the hippocampus is especially responsible for the maturation process of a memory, but long-term memories are stored mainly in the cortex. Scientists don't know exactly the steps by which this process happens, but is already known that if the hippocampus is damaged by injury, the ability to store long-term memories can be completely lost. We also know for sure that sleep is fundamental for memory consolidation. So, if you think about being awake all night to study for an exam, well, you better think again. It won't work. I'm sorry. Another interesting fact is that when you recall a memory, you're actually reconstructing it. You've probably heard this in school, since you're reactivating the networks of brain regions that store that memory. In other words, you're reactivating that engram. So, for you students, a science-baked type to remember and retain information in long-term memory is to understand the importance of repetition, especially repetition in different contexts to avoid boredom. Me, João Vitor, intellectually gifted, I just hate repetition, so I need different contexts to learn something new. That's how I learn language. That's how I'm speaking English right now. That's how I study. I interconnect new information with various structures of knowledge I already have consolidated. So, when I'm reading Piaget in French during my lunch break, I came across a new word, translated and understand it in the context of that sentence. On the next page, the new word might reappear, perhaps in a new context, and certainly in a different sentence, reinforcing my understanding and memory of it, and therefore the synapse related to the new word. Folks, just a quick note. If you hear any background noise, I apologize, but I just can't isolate the entire house. I don't have the resource to do it. So, in the final audio, I'll try to treat and remove this noise, but it's impossible. I don't live alone. I live in the hood, so please understand if you get meows or someone shouts on the background, just ignore it and pretend it didn't happen. And stay focused on the content. Perfect? Thank you very much. Let's continue. As I continue reading in the following days, chances are high that we record the word in long-term memory. The same goes for other cases. But if you have a normal brain and can bear repetition, the spaced repetition method can save your study. Apps like Anki, Mesmerize, etc., which use flashcards, are very useful tools. Having a notebook and taking handwritten notes is also very effective, as it works both declarative and explicit memory or implicit or model memory, since you're making motor movement to help form the memory. But let's not lose the thread of the synapse. If you want a video just about studying methods, comment below. Since we talk about memory in rotation, how about we now talk about forgetting and disease that affect memory? Considering all the neurology related to memory we've seen so far, when you think about forgetting short-term memories, it's easy to understand that this forgetting happens as a mechanism to save energy and increase the efficiency of brain processes. Since this memory primarily operates in the prefrontal cortex, we can understand the prefrontal cortex as a kind of filter that works together with the hippocampus in the entire limbic system to determine whether information is relevant or not, whether it should be stored in memory or not. The role of the limbic systems goes much further, as we know that memories with emotional value are much more easily recorded in long-term memory. So think for example about trauma. Since it's associated with a very strong emotion, it's easier for the brain to record that information as it may be more relevant. So, post-traumatic stress disorder, in this neurological sense, means a super memory because of its emotional relationship with the event. So, if you also remember the dendrites, the message receiving part of the neuron, remember that I also mentioned that they're constantly forming new connections and breaking old ones. That is a classic analogy that helps us to understand this process. Think of a virgin forest. To cross it, we need to create a trail through the underbrush. If someone needs to use that trail the next day, it will still be there. But if months later, someone needs to use the same trail, there will probably be no sign of it, as the underbrush has grown and covered it. Similarly, this happens with our synapses and engrams. If these connections between neurons are not reinforced with some frequency, they will weaken and be lost. This process is called pruning, and it's a natural mechanism. But when it's not natural, well, you've probably been in a situation or know someone who on some weekend drank so much that the next day they couldn't remember almost anything from the night before. Now I'm gonna dub this Brazilian meme for you. What did I drink? Why did I drink? It's not beer? It's not alcohol? Guys, it is just me who drinks. Just kidding. Let's come back. This process is called retrograde amnesia. Amnesia or memory loss can result from any blow to the brain, an injury, a strong heat, a disease, surgery, drugs, or electroconvulsive therapy. As I mentioned before, both social drinking and chronic alcoholism are linked to memory loss, given that alcohol acts as a depressant on the nervous system. That's why you can enter an alcoholic coma if you drink too much. Ethanol potentiates GABA, which is an inhibitory neurotransmitter. Ethanol, by potentiating GABA, decreases the activation and activity of the hippocampus, decreases the release of the neurotransmitter glutamate, and glutamate is the main neurotransmitter related to the hippocampus. That's where it reacts, doing long-term potentiation. Remember long-term potentiation? So, that's where it acts, doing this process. Do you see how these things connect? How the processes relate? I hope it makes sense to you. High levels of stress can also cause amnesia. There are various forms of amnesia. This disorder can be temporary, as with alcohol, or irreversible. We can lose a small or large part of our memory. The more intense the blow to the brain, the longer the period of forgetfulness. The loss of memory of events that occurred before the trauma is called retrograde amnesia. Remember, as in the case of alcohol I mentioned, and is usually associated with anterograde amnesia, which is the forgetting of events that occurred after the shock. We know that much of the discoveries of neuroscience, neurology, and related fields are due to the study of brain injuries and the deficiencies caused by them. Think for example about the fact that patients with Alzheimer's, despite not remembering the names of their own children, they can still communicate in their native language, walk, and in many cases even play instruments and recognize songs that are part of their history. Alzheimer's disease is a neurodegenerative pathology. Remember that at the beginning of the video, I talk about declarative memory, which is semantic, biographical, and linguistic memories, that is explicit memory. So, Alzheimer's mainly affects this last type, which is why Alzheimer's patients have difficulty to remember names, dates, and facts about their own lives. Synapses are pruned, killed, throughout the development of the disease, which is why it's called neurodegenerative. The condition mainly affects the hippocampus, and, as we've seen throughout this video, it's clear to understand its relationship with memory loss and memory consolidation. I hope you've managed to absorb the information I give in this video. Watch it again to get this knowledge into your long-term memory. Please comment below your thoughts about this video. I will leave 2 videos here on the final screen so you can continue learning more about psychology and the human brain. I'm João Vitor, and I'll see you in the next video. See you.